of artificial satellite and their function. Now let's see the next topic of this chapter, space vision, that is orbit of artificial satellite. Orbit of artificial satellite means the orbit in which the satellite used to revolve around the Earth. So there are different orbits in which the different types of satellite used to revolve, that I will explain you later on. Here, first of all, let's see what is the critical velocity required for an artificial satellite to set in a specific orbit. So, what is the critical velocity? Let's see here. Here, Earth, capital R is the radius of the Earth, and suppose this is an artificial satellite. We have to set this artificial satellite in this blue colored orbit, and for that we need an critical velocity at this point which is tangent to this orbit. So to find out the derivation or formula for the critical velocity, let's see which are the terms required. Suppose small m is the mass of the satellite, h is the height of the satellite from the Earth, that is this h from the surface of the Earth, this is the height of the satellite, and small r is the orbital radius of the satellite from the center of the Earth, means here. Suppose this is the center of the Earth. From here, this distance small r is the orbital radius. Now, this is the surface of the Earth. From here, with the help of the launching pad, we used to launch the satellite at certain height. When the satellite reaches this height, at this point we have to provide an velocity to this satellite, and that velocity is vc. For that, let's see the derivation. As we have studied in our first chapter, that on this satellite there is a centripetal force applied, which is equals to mv square divided by r plus h, that we have studied in the first chapter, gravitation. And this centripetal force is equals to gravitational force applied by the Earth. So both the forces are equal. So we are going to use this concept, and we will write the formula of centripetal force first. And the gravitational force, the formula for the gravitational force we have studied in the first chapter, that is Newton's universal law of gravitation. Capital G, capital M, mass of the Earth, small m, mass of the satellite, divided by r plus h whole square. That formula. Capital G is universal constant. Now we will simplify this. Here, small m and small m get cancelled. So Vc square is equals to, shift it to other side, capital M, capital G, capital M divided by r plus h whole square into r plus h. This term get cancelled. So finally, Vc square is equals to capital G, capital M, r plus h. Further, Vc is equals to, under the rule, capital G, capital M divided by r plus h. So this is the critical velocity which we have to provide to a satellite to set an orbit in a specific orbit. Let's see, this velocity depend upon which factor. Capital G, universal constant, capital M is the mass of the Earth, capital R is the radius of the Earth, and the h is the height of the orbit from the surface of the Earth. So these are the factors on which the velocity depends. ध्यान से देखो, यहाँ पर आप देखोगे कि यहाँ पर कहीं पर भी स्मॉल m मास ऑफ द सैटेलाइट नहीं है. So the critical velocity does not depend upon the mass of the satellite. Okay, so it is depend upon only capital G, capital M, R and H. Does not depend upon the mass of the satellite. So this is the formula for the critical velocity. You have to use this formula to solve the numerical directly.
Now students, there are different types of orbits of satellite depending on the different height of the satellite above the Earth's surface. It is due to their different functions. Now students, let's study the first orbit, that is HEO. Here the orbit of this satellite is parallel to equator. Now students, observe this animation carefully. आपको इस अर्थ सरफेस पर एक येलो शेडेड पोर्शन दिखाई दे रहा होगा. This particular yellow shaded portion is the only region which is observed and studied by this satellite. So it is in a contact with only one particular region or same area of Earth. That's why it is called stationary or geosynchronous satellite. Now the next orbit is MEO, medium Earth orbit. Here this satellite used to revolve above the poles of the Earth, North Pole and South Pole. It is used to study the polar region, and that's why it is called polar orbits. So these are the two orbits, polar orbits and HEO, that is geosynchronous satellites orbit, which are perpendicular to each other and revolve in this way. Now the next is low Earth orbits. If the height of the satellite orbit above the Earth's surface is in between 180 km and 2000 km, the orbits are called low Earth orbits. So this satellite is very close to Earth as its height is very low, between 180 to 2000 km. As the height of these satellite is low, that's why it complete one revolution around the Earth in 90 minutes. These satellites are used for scientific experiments and atmospheric studies. Moreover, International Space Station and Hubble telescope also revolve in low Earth orbits. Now let's study more about medium Earth orbit. The height of this orbit is near about 2000 to 35,780 km. In these orbits, the satellites complete one revolution in 2 to 24 hours. These satellites used to study the polar region of the Earth, that is the North Pole and South Pole, that is to study the atmospheric and climatic changes that occur on the North Pole and South Pole, and various other things about these two poles. Now let's study more about high Earth orbit. As we have studied the three orbits, low, medium and the last is high Earth orbit. Height of this orbit is greater than or equals to 35,780 km. That's why to complete one revolution around the Earth, these satellites used to take 24 hours. It is almost equals to the 24 hours of Earth, that is one day. So they can observe a specific portion or region of the Earth continuously. Therefore they are used in applications like meteorology and for carrying signals for telephone, television, radio, etc. So these are the three different types of orbits of the satellites as per their height from the surface of the Earth and their different functions.